Mr. Ramesh Chandra and taking a lecture on Introduction to Trigonometry. Let's understand the complementary angles. What are complementary angles? So here we have a right angle triangle, right angle at. So here you can observe that this angle is 90 degree. So the sum of these two angles, that is angle A plus angle C, is equal to 90 degree. This implies C is equal to 90 degree minus A angle. So the sum of these two angles is 90 degree. Any two angle having some 90 degree are said to be complementary angle, like 35 degree, 55 degree are complementary angles since their sum is 90 degree. And again you can have another example, 53 degree and 37 degree. These two are complementary angle. So any two angle having sum as 90 degree are said to be complementary angle. Like here you can see, if A plus C is 90 degree, then A and C are complementary angle of each other. Let's find the trigonometric ratio for complementary angles. Sine of angle A, sine of this angle A can be written as BC upon AC. BC upon AC. If we think a similar way, then the ratio BC upon AC with respect to this angle can be written as BC upon AC can be written as cos of C, cos of this angle C. But what is cos C? Cos C is cos of, if we replace C by 90 minus A. Then what are you getting here? You will get here sine A is equal to cos 90 minus A. So we have a formula here. Cos of 90 minus A is equal to sine A. So this is the first angle that this is the first formula of complementary angle that we have derived. Similarly, if we think of sine of 90 minus A or sine C, that is sine of 90 minus A, that is equal to sine of C is equal to AB upon AC. AB upon AC. And the same ratio AB upon AC with respect to A can be written as cos of A. Hence another formula we have sine of 90 minus A is equal to cos of A. So we have these two formula that we have derived. Sine 90 minus A is equal to cos A and cos 90 minus A equal to sine A. So similarly we can have a formula for any angle like sine 90 minus theta is equal to cos theta. Instead of A, we write theta. Similarly, cos of 90 minus theta is equal to sine theta. So these two are very important formulas that we need to remember, and these are two very helpful while solve problem. Let's generate proof for other formula like tan 90 minus theta, cot 90 minus theta. If we have tan of 90 minus A, 90 minus A, with respect to this we will have AB upon BC. With respect to this angle A, AB become base and this is the perpendicular. So this is equal to cot of A. Hence we have formula tan 90 minus A is equal to cot A. This is formula number 3. And similarly, if we think of cot of 90 minus A, cot of 90 minus A, this angle is equal to base upon perpendicular, that is BC upon AB. And with respect to the angle A, BC upon AB become tan of angle A. So we have another formula, cot 90 minus A is equal to tan A. This is formula number 4. So these are the formula for angle A. In general, we can have tan 90 minus theta is equal to cot theta, and cot 90 minus theta is equal to tan theta. Very simple, you can see. If you want to apply this formula, you can have like tan 73 can be written as tan of 90 minus 17. As you can see, 17 plus 73 is 90. So 90 minus 17. So this can be written as cot 17 as per the formula. Tan 90 minus theta equal to cot theta. I have written theta as 17 degree. So this will equal to cot 17. This implies tan 73 is equal to cot 17. Sec of 90 minus A is equal to, sec 90 minus A angle is equal to, sec is hypotenuse upon base, that is AC upon BC. With respect to angle A, AC upon BC become equal to cosec A, cosec A. Hence, sec 90 minus A is equal to cosec A. So this is formula number 5. In the same way, cosec 90 minus A hypotenuse upon perpendicular, that is AC upon AB, AC upon AB. Now with respect to angle A, AC upon AB become equal to sec of angle A. So cosec 90 minus A is equal to sec A. So this is formula number 6 for complementary angle. So in general, we can say sec 90 minus theta is equal to cosec theta, and cosec 90 minus theta is equal to sec theta. So let's summarize these 6 trigonometric ratio for complementary angles. These are the results that we need to remember in general. Sin 90 minus theta equal to cos theta, and cos 90 minus theta equal to sin. And similarly, tan 90 minus theta equal to cot theta, and cot 90 minus theta is equal to tan theta. And sec 90 minus theta equal to cosec theta, and cosec 90 minus theta equal to sec theta. So these are the 6 trigonometric ratios for complementary angles. Now question is how to apply these formulas while solving problems. So let's have an example here. Sin 52 degree upon cos 38 degree. First you need to observe that the sum of these angles is equal to 90 degree. 52 plus 38, this is 80, and 8 plus 2 10, so this become 90. So sum of these two angle is 90, so 52 and 38 are complementary angle. This implies we can write it as sine of 90 degree minus 38 degree upon cos 38 degree. You can see 90 minus 38 is 52. So what we have, sine 90 minus theta is cos theta. So theta is 38 degree. Hence this become cos of theta. Theta is 38 degree. So cos 38 upon cos 38 degree. And you can say if we cancel them, then this become equal to 1. So you can apply a complementary angle in solving such kind of problems. Let's move on the next subtopic, that is trigonometric identity. Now, what is an identity? To understand an identity, let's have some equations here. As you can see, 2x minus 1 equal to 0. This is one equation. This is another, and third is another equation. Let's solve the first one. So 2x minus 1 equal to 0. This implies x is equal to 2x is equal to 1. So x is equal to 1 by 2. So what it is? X equal to 1 by 2 is a root of the equation 1. So you can say x equal to half is the only value that is satisfying this equation. As you can see, 2 1 by 2 minus 1. You can have 1 minus 1 is equal to 0. So half is the only value that is satisfying this equation. And if you put x apart from half, any other value apart from half, then this will satisfy. Let's say if we put x equal to 1, then 2 into 1 minus 1. So 2 minus 1, that is 1, and that is not equal to 0. So other value of x will not satisfy. Hence the equation will have only one root, that is x equal to half. Now let's move on another equation, equation number 2, that is x square minus 3x plus 2 equal to 0. So we can factorize it as x minus 2 into x minus 1 equal to 0. So x equal to 1 and 2 are the roots of the equation this. So you can have 1 and 2 are the only values of x which will satisfy this equation, and apart from 1 and 2 other will not satisfy. Like x equal to 0, if we put x equal to 0, 0 will not satisfy this equation. As you can see, 0 square minus 3 into 0 plus 2 is equal to 0. So you can see 2 equal to 0, which is not possible. So it means that x is equal to 0 is not satisfying. So these are the only two values that are satisfying. So this is an equation. Now in third case, you can observe one thing, that this is true for all the values of a and b. This is true for all values of a and b. If we take like if we take a as 1 and b as 0, then we will have 1 plus 0 square is equal to 1 square plus 0 square plus 2 into 1 into 0. So you will have 1 is equal to 1 square plus 0 plus 0. So 1 is equal to 1. You can take another values of a and b, like a is equal to 2 and b is equal to minus 1. So what we have, 2 minus 1 whole square is equal to 2 square plus minus 1 ka whole square plus 2a is 2 and b is minus 1. So this is 1 square is equal to 2 square is 4 plus minus 1 square is 1, and this is minus 4. So you can see you will get cancelled 4. So 1 is equal to 1. So you can see, observe one thing here. This is the equation which is satisfying for every value of a and b. Hence this is goes under identity, and under is the category of identity. So you can see these two are the equations, and this is what we call identity. So let's define the identity. What is an identity? An equation is said to be an identity when it is true for all values of variable involved. As you can see in previous case, these were the identities since it was true for every values of a and b. Let's have some trigonometric identities. Consider a triangle ABC as shown here, and angle A is denoted by angle theta. Now since ABC is a right angle triangle, then it will apply Pythagoras theorem. AB square plus BC square is equal to hypotenuse square. Now if we divide this by AC square, you can see this is the relation that we will get. This imply AB upon AC whole square plus BC upon AC whole square, and this is equal to 1, since these two are same. Now with respect to angle theta, AB upon AC, AB upon AC is the cos theta, and BC upon AC, BC upon AC is the sin theta. So the formula become cos theta plus sin theta, cos theta whole square plus sin theta whole square is equal to 1. Now cos theta square can be written as cos theta into cos theta, and even you can write it as cos square theta, and this is not equal to cos square theta square. This is not equal to cos square theta square. This is the symbolic representation that is saying that cos theta whole square. It means that cos theta into cos theta. Hence, we have the formula cos square theta plus sin square theta equal to 1. This is the formula that we have derived recently. And if we rearrange them, then we will get, if we take sin square theta that side, then we will have 1 minus sin square theta equal to cos square theta. Similarly, if we take cos square theta that side, means 1 minus cos square theta equal to sin square theta. So these are the same identity, sin square theta plus cos square theta equal to 1, and we have rearranged them. We can apply any one of them whenever it required in the question. Let's have another identity, the same Pythagoras theorem that we have applied here. AB square plus BC square equal to AC square. Now we are dividing it by AB square. AB square. So you can see here, this imply 1 plus BC upon AB whole square is equal to AC upon AB whole square. Now with respect to this angle theta, we can have BC upon AB, BC upon AB as tan theta. 1 plus tan theta whole square is equal to AC upon AB, AC upon AB, that is sec theta whole square. So the identity become 1 plus tan square theta is equal to sec square theta. 1 plus tan square theta equal to sec square theta, and if you rearrange them, then you will have another two formula as sec square theta minus 1 equal to tan square theta, and sec square theta minus tan square theta equal to 1. You can apply any one of these three identity. Again, we have another identity, the same Pythagorean triplet we have, the same Pythagoras theorem we have here. AB square plus BC square equal to AC square. Now we are dividing it by the length BC square. So BC square, you can see this imply AB upon BC whole square plus BC square upon BC square is equal to 1. This is equal to AC upon BC whole square. Now with respect to this angle theta, AB upon BC, AB upon BC is equal to cot theta. So 1 plus cot theta whole square is equal to AC upon BC, AC upon BC is equal to cosec theta whole square. Hence the identity become equal to 1 plus cot square theta is equal to cosec square theta, and if we rearrange them, then we will have cosec square theta minus 1 equal to cot square theta, and then cosec square theta minus cot square theta equal to 1. So till now we have derived three trigonometric identity, and let's have them together. These are the three main and important identity that we need to remember. First, sin square theta plus cos square theta equal to 1, and then second one, 1 plus tan square theta equal to sec square theta, and third one, 1 plus cot square theta equal to cosec square theta. Let's have problem solving ability. Evaluate sin theta cos theta, sin 90 minus theta upon cos 90 minus theta plus cos square 90 minus theta. Answer for this question is 1. So here is the solution. Sin theta into cos theta, and sin 90 minus theta is cos theta upon cos 90 minus theta is sine theta plus cos 90 minus theta is sine theta, and this is whole square. This means that sine theta whole square. So you can cancel this sine theta by sine theta, so it become cos theta into cos theta is cos square theta. Cos theta is not like cos into theta. You need to remember, this is not like cos into theta. This is cos of theta. Cos of theta. This is symbolic representation. Cos of theta, and not these two are not two values. So cos theta into cos theta is cos square theta plus sine theta whole square is equal to sine square theta, and sine theta square is equal to sine theta into sine theta, and this is not equal to sine square theta square, but what this is equal to sine square theta. This is the symbolic representation, and it is saying that sine theta into sine theta. What it is? Cos square theta plus sine square theta. Recently we have seen this is the identity, and hence it is equal to 1. Let's solve another problem. If alpha plus beta equal to 90 degree and alpha is equal to 2 beta, then cos square alpha plus sine square beta equals. Answer to this question is half. Since alpha plus beta is equal to 90 degree and alpha is equal to 2 beta. So let's put alpha equal to 2 beta at here. So 2 beta plus beta is equal to 90 degree. This means 3 beta is equal to 90 degree. Hence beta is equal to, if you divide 90 by 3, you will get 30 degree. So beta is equal to 30. This implies alpha is equal to 60 degree. Alpha equal to 60 degree. Now we need to find the value of this. So cos square alpha is 60 degree plus sine square beta. Sine square beta is 30 degree. Now we know that cos 60 is half. So this is half square plus sine 30 is also half. So this is half square. Hence we will get 1 by 4 plus 1 by 4, and hence this is equal to 2 by 4, and that is equal to half. So half is the answer for this question. Let's have another problem. Prove that cot theta minus tan theta equal to 2 cos square theta minus 1 upon sin theta into cos theta. So let's have a proof. Taking left hand side, cot theta minus tan theta. If we resolve in sine and cos, then we will have cos theta upon sin theta minus sin theta upon cos theta. If we take LCM of these two, then we will have sin theta into cos theta as LCM. So to have sin theta into cos theta, we need to multiply it by cos theta, numerator and denominator. In the same way, to have sin theta and cos theta denominator, we need to multiply by sin theta and sin theta. So what we are getting here, cos theta into cos theta is cos square theta minus, and here we have sin square theta. So we have this relation. Now you need to understand that denominator is sin theta cos theta, that we have already been achieved. We need to get 2 cos square theta minus 1 at the numerator. So we will not change cos square theta, we will change sin square theta in terms of cos square theta, and we have identity for the same. Cos square theta minus sin square theta can be written as 1 minus cos square theta upon sin theta into cos theta. So this implies cos square theta minus 1, and minus into minus is plus cos square theta upon sin theta cos theta, and in the next line we will have a proof. Cos square theta plus cos square theta is 2 cos square theta minus 1 upon sin theta into cos theta. Hence proved. Let's move another problem. If cos A plus cos square equal to 1, then the value of sin square plus sin to the power 4a is, we have 4 options, A, B, C and D. So here is the answer for this question. You can solve your own and match your solution. Answer to the question is A part. We need to find sin square plus sin to the power 4a. So we have here cos A is equal to 1 minus cos square A. So what we can have, 1 minus cos square A is sin square A. So this implies we can replace sin square A as cos A. So call this V1. Now we need to find the value of this, that is sin square A plus sin to the power 4 can be written as sin square A to the whole power 2. Now we can replace, we can use this relation sin square equal to cos A, that is cos A plus cos A whole square, that is this implies cos A plus cos square A, and hence this is equal to cos A plus cos square A is equal to 1. So we need to find the value of this, and we are getting this as 1. Hence 1 is the correct answer. So A is the correct answer for this question. Let's have another problem. If tan theta equal to x sin phi upon 1 minus x cos phi and tan phi is equal to y sin theta upon 1 minus y cos theta, then find x upon y. So there are 4 options, A, B, C, D. We have 4 options here. Answer to the question is B. Let's have solution for the question. We can have tan theta is equal to x sin phi upon 1 minus x cos phi. We multiply it by this denominator, then we will have tan theta minus x tan theta into cos phi is equal to x sin phi. We take x that side, then we will have tan theta is equal to, we will have x times tan theta cos phi plus sin phi. Hence x equal to, this implies x is equal to tan theta upon tan theta cos phi plus sin phi. Now if we multiply numerator and denominator both by cos theta, so cos theta, so what we will get here? We will get tan theta is equal to sin theta upon cos theta. If you multiply by cos theta, the numerator will get x equal to sin theta upon tan theta into cos theta, tan theta into cos theta. You can get sin theta upon cos theta into cos theta. So you can cancel cos theta and this will give you sin theta. So if you multiply cos theta and tan theta, you will get sin theta into cos phi plus cos theta into sin phi. Call this B1. Now let's solve second equation same way. You can observe these two. These two are very similar relation. We have theta in place of phi here and y in place of x and theta in place of phi. Similarly, you can have another relation. You can write y is equal to. So what we need to have? We need to replace theta by phi. So this becomes y is equal to sine of phi upon. We need to replace theta by phi and phi by theta. So this is sine of phi and cos theta plus cos of phi and sine phi need to replace by theta. So sine theta. So this is the second relation. By similarly, you can also derive it by the same way that I have derived here. But if we take some extra effort, then we can directly write this relation. You can observe here one thing: the denominator of y and x are the same, as you can see here. Cos theta into sin phi, cos theta into sin phi plus sin theta cos phi, sin theta cos phi. So if we have x upon y, we need to find the value of x upon y. So we will have sin theta upon the denominator divided by sin phi upon the denominator. So these denominator are same, so you will cancel them. So hence sin theta upon sin phi. So you can say B is the correct option of the question. So here we have exercise 4 for you. You can solve these questions. There are 6 questions in this exercise, and these are related to the topic that we have studied in this video, and these are the answer key for the questions. Solve your own and have build up a confidence in solving the problem related to trigonometry. Thanks.